Today's video is going to be on adding and subtracting algebraic fractions. So we've got three learning goals today. Nope, two learning goals today. The first is that you'll be able to identify algebraic fractions, and the second is that you'll be able to add and subtract algebraic expressions accurately so that you are able to simplify them. Okay, so an algebraic fraction is simply just any fraction that has an algebraic expression as either the numerator or the denominator or both. So on the left here, you can see we've got normal fractions. These just have numbers as your numerators and numbers as your denominators. On the right though, we have a variety of algebraic expressions. So this first one, algebraic fractions. This first one has an algebraic expression as our numerator. Our second algebraic fraction has an algebraic expression as the denominator. And our last one, this algebraic fraction has an algebraic expression for the numerator and for the denominator. So they're quite easy to spot. Okay, so when we're adding and subtracting algebraic fractions, the rules are the same as when we add and subtract normal fractions. So whenever you add and subtract fractions, you need to have a common denominator, and that's the same for algebraic fractions. So the lowest common denominator of two algebraic fractions is simply the smallest multiple of both the denominators. So for instance, we've got x over 3 and 2y over 5. So the first thing we have to do is find the lowest common multiple or lowest common denominator of 3 and 5. So for a start, we can list all our multiples of 3. So we've got 3, 6, 9, 12, 15, and so on, for 5, 10, 15. And there we go. Our lowest common multiple is 15. So to convert our fractions, we'll do x over 3, and to turn it into a fraction with a denominator of 15, we have to multiply by 5. So our numerator, x times 5, is 5x, and our denominator, 3 times 5, is 15. We also have to do the same for our 2y over 5 fraction. So we've got 2y over 5. We want to change it to have a denominator of 15, so we have to multiply both by 3. So 2y times 15 is 6y. Sorry, 2y times 3 is 6y. 5 times 3 is 15. So now we've got two fractions, both with the same denominator of 15. So I'm actually going to have to clear my screen just so I've got enough space. Actually, no, I'll just draw a column here, sorry. So I've got 5x over 15 plus 6y over 15. If you were setting this out in your book, continue to go down the page. I've just, for some reason, taken up a lot of space and kind of run out. So then I can add 5x plus 6y. We know from our previous lessons that we can't actually add those terms because they're not like terms. So we're left with 5x plus 6y over 15. So that's our answer for the first one there. Now I will clear the page, do the second one. So our second one, we've got 4 and 5, and we're going to find our lowest common multiple. So again, multiples of 4 to start off with. We've got 4, 8, 12, 16, 20, multiples of 5, 10, 15, 20. Voila, our lowest common multiple is 20. Then we have to convert both our fractions. So we've got x over 4, and we want our denominator to be 20, so we're going to multiply both by 5. That will leave us 5x over 20. Our second fraction, we've got y over 5. Our lowest common denominator is 20, so we'll have to multiply both by 4, which leaves us with 4y over 20. From there, we can go on to add our fractions. So 5x over 20 plus 4y, that's a 4y over 20. 5x plus 4y, they're not like terms, so again, we can't add them, so we'll just leave it as 5x plus 4y, and our denominator stays as 20. So quite straightforward, exactly the same as the way we normally add fractions together, just this time we've got some algebraic expressions in there as well. Again, we've got a bit more of a more complex one here. So we've got 7p over 6 plus 2p over 5. So starting off, going to find our lowest common denominator. So what is our lowest common multiple of 6 and 5? So we'll start with our multiples of 6. 6, 12, 18, 24, 30, of 5, 10, 15, 20, 25, 30. There we go. Our lowest common multiple of both is 30. So then we're going to convert those fractions. So we'll have 7p over 6, and to get our denominator to be 30, we're going to have to multiply that by 5. So 7p times 5 is going to give us 35p over 6 times 5, which is 30. Our second fraction, again, I'm going to divide my page in half. Just keep working down your page in your books. 2p over 5, have to multiply both the numerator and the denominator by 6 to get our fraction with 30 on the bottom. So 2p times 6 is going to give me 12p. 5 times 6 is going to give me 30. And then I can add my fractions. So that equals our 35p over our 30 plus 12p over 30. Now, this time we actually do have like terms in our numerator, so we can add them together. So we can do 35p plus 12p. Sorry. So 35 plus 12 is going to give me 47. 47p over 30. It's that simple. Okay, so we've got another example here. So we're just going to simplify this expression. So this time our denominators are 3 and 10. So we're going to try and find the lowest common multiple of 3 and 10. You can probably do it in your head, but I'll start listing them now. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And for 10, we've got 10, 20, 30. There we go. Our lowest common multiple of both of those numbers is 30. So now what we're going to do is we're going to convert our fractions. 10u over 3. To get to a denominator of 30, we're going to have to multiply it by 10. 10u times 10 is going to give us 100u. 3 times 10, 30. 3v over 10, we're going to have to multiply by 3. And that's going to give me 9v over 30. Sorry again. So from there we can add our fractions. 100u over 30 plus 9v over 30. We don't have like terms. 100u and 9v are not like terms, so we can't really do much with those. We'll just leave that as 100u plus 9v over 30. And that's our answer there. Okay, I might skip that one. We'll move on to C. So C is a little bit more complex. So we've got 2t plus 7p. So we know 2t is the same as 2t over 1 plus 7p over 2. So we now have to find our lowest common multiple of 1 and 2, which I'm not even going to write that out. You all should know that that is 2. So to convert, we're going to have to do 2t over 1 multiplied by 2, which will leave us with 4t over 2. From there, we can add our fractions. So 4t over 2 plus 7p over 2. 4t and 7p are not like terms, so we can't add them. So 4t plus 7p over 2. So that's the end of our video today. Hopefully, with all those examples, you've kind of got the hang of it. It's exactly the same as adding normal fractions, just we've got some unknown variables in there as well. Also, I'll apologise for coughing throughout the video. Hopefully that didn't interrupt you too much. Hopefully this is straightforward. Come and see me if you do have any questions though.